Okay, hello everyone. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHO.
Good evening, sir.
Good evening to all. I think wait for 1 to 3 minutes for others to join, then start the classes.
Sure.
Sorry. Okay, let's start the session. In previous class, we learned about the solar PV, how it work, and how we will connect it a current source. It will be denoted like a current source followed with anti diode. Then for the practical uses, there is a shunt resistor and a series resistor. This is the equivalent circuit of a solar PV cell. So the diode is a shunt resistor, is the series resistor, diode current and shunt current. This will be total IPV. This will be PV voltage. And previously we draw this voltage current characteristics. A constant current minus of diode current will be looks like that. The open circuit voltage, this one is the short circuit current. For the any circuit, if any circuit have short circuit, it means suppose there is a voltage source and a resistance. This is the terminal voltage Vt and I Vr. If there is an open circuit and short circuit, Means what? Suppose if I have connected the load here RL, then what is the value of RL when the circuit is short circuited, and what is the value of RL when open circuited? Now this is the voltage of VT. There is a current, same current is flowing I. If I short circuit, it means two terminals are short circuited like that. If both terminals are same, at that point the voltage is be zero. If the two terminals are short circuited, it means two terminals are same terminal. This terminal and this terminal will same. Then voltage will be short circuit. Then what is the impedance of the circuit or resistance of the circuit? RL V by R. V by I. Vt is 0. 0 by I, it means 0. Load resistance is 0, it means there is a short circuited. And load resistance will be infinite when open circuited. Let's check this one. This will be infinite. Oh, sorry, this will be open circuited. And Vt have some voltages, but current will be 0 because of the open circuit. And what is the RL? Vt divided by I will be 0, then Vt divided by 0, it will be infinite. It means open circuit, this will be a short circuit. Same thing here, this will be open circuit, it means these two terminals are open. Then that time a voltage of this PV is VOC. If both terminals short circuited, then what is the maximum current or how the short circuit current will flowing through the through this? It means voltage will be 0. This will be a short circuited. Same thing if you take a load line varies from 0 to or infinity. Or infinity, it means load line resistance will be infinity, it means open circuited, resistance will be 0, it means short circuited. Then all of the condition load is vary from 0 to infinity. Same thing here. This will be here, resistance will be infinite, and here resistance RL will be 0, like that. The, this is representation of a cell only, not a whole PV system. This will be a cell only. A cell voltages is maximum like 0.6 volt. Same thing. You know about the depletion layer. This voltage maximum voltage is 0.6 volt open circuit voltage. And this donation of this circuit PV cell is donated by like that. A message box, IPV and VPV. This is the a cell. But you know about the voltage, if you requirement of the higher voltage and higher current rating, then the number of this cell are connected in series and parallel to increase the voltages and current. If number of cells are connected in series, it means the overall voltage will be increases, and same number of cells are connected in parallel, then there is the current, short circuit current or current will be increases of the system of the PV array. The whole PV panel, you see, I think a PV panel is a number of cells are connected in series and parallel. There are 100 cells, 200 cells, like that, 500 cells, like that. If you connect it series and parallel, then you can increase the voltage and current. But there is a problem when you connected the two cells are in series and parallel. Because of the manufacturing, you can't be say the both are cells are same, are identical. It will be happen only when the ideal cases, but in practical cases there are some other resistances and series resistances. There is a manufacturing error. But the another problem is the shadow of some trees or some other like that. If a shadow is there, then it will be partially shaded, or some of the portion or some of the cells of the panel, then there will be performance decreasing of there. if some bus it may be a series connected cells or it may be a parallel connected cells or silos. There are a lot of things as possible. Then first we learn about the what to happen if you connected a two cell in series. In place of this one, I using this notation. So one cell, this is another cell. Then overall voltage. This is overall current. And this will voltage is be a V1. This voltage is V2. Then what is the overall voltage and current? Suppose a cell like that, VOC1 for the V1, and this is the VO, this is ISC1. In the ideal cases, if the both are cell are identical, then you can say same thing VOC1, VOC2, this is ISC, sorry, ISC2. In series connection, you all have to know about the series connection. Voltage will be increases, current is same in series, and same thing happen here also. Voltage will be increases, which means double of this one. Overall voltage is VOC is equal to VOC1 plus VOC2. Current is will be same in series connection. And current will be same, but voltage will be increases like that. Sorry. This is the overall characteristic when both are identical. But if this is not possible in practical cases, then what happen if there is a non-identical series connected cell? Non-identical, it means the current rating will be different. A voltage is different, it means simply you can add the voltage both V1 and V2 because of the series. But there is a problem in current rating. If the both cells are deliver the different current at any point, then which one current you can take? And previously we learned about the current source. There will be 5 ampere, 4 ampere. There is an option. Then there is a problem. You can't be connected two current source or two different current source in a series. Same thing here also. A PV cell is a constant current and the anti-parallel diode, then a resistance in series and a resistance in parallel. Yeah, shunt resistor. Same thing. There is a current source system. Then current source and it can't be connected different current source in a series. If you connect them, then what happen? There is some irritants. There is some power loss because of the lowest current rating. Um, and the maximum current is flowing only which one is the low current rating, not a higher current. If a high current is flowing there through it, then some of the power are dissipated in that cell because of voltage polarity. It will voltage will be zero. Wait, I show you. Suppose there is a two cell like that. ISC2, then this will be ISC1. What happened if you take a different current rating, load current? The operating point is depending on the load current. How much load you have connected at the terminal of the PV cell. Two PV cells are connected in series. Then what is the load RL here? You connected. It depends on the operating point. If you know the I and V characteristic, then what is the operating point and how it varies V and I. If you suppose any point, it vary from V to Y. V is at this point, it means the current is zero. Current is zero, it means open circuit. Open circuit, it means RL will be infinite. Same thing at the current axis. What is the RL? RL will be 0 because of the voltage is 0. It means the short circuited. Then it will vary it from 0 to infinity. This is the load line. Any load line, you can put any load at the terminal of the PV panel or PV cell. You can connect any load line. The load line varies from 0 to infinity only. You can put a short circuit, open circuit, or some resistances. You can put some resistances only. There is just some resistance value. That value depends on the current. Sorry, the current PV currents depend on that value only. What is the operating current remain? Same thing here. If you operate it at some point like that, suppose you operated that point like that, there is some current and some voltage here. Current is this one and voltage is this one, and there is some resistances RL or something. It may be something that is operating point. Then what happened at that point? So what is the voltage and current of overall? Then there two sources are connected in series. Then both sources can deliver that current. A maximum current rating of this one of cell 1 is this one, and maximum current rating of cell 2 is this one. Then both the cells are delivered that current. Then there is no matter, then nothing will happen. Same voltage is double of the voltage of V1 plus V2. Overall voltage you can be delivered. At that point, this will be the total VT. It will be VOC1 plus VO. Sorry, V1 V2 can V1 plus V2. It will not or at that point it will be a open circuit voltage, then you can say V1 C1 plus VOC2. But at that point it will like going like that. There is some differences between them. This is the open circuit voltage, this is not open circuit, and there will be some reduces voltage here. You can put that value is Vt is V1 plus V2 something. Okay, fine. Here is fine. Suppose if you increase the if you decrease the load resistance, it means you increase the load. There is a difference between load resistance and load. Load, it means the current directly proportional to current. If you increase the current, it means the load, you increases the load, but load resistance will be decreases. Sorry, don't confuse them. Any you know about V by I, suppose RL. If you increase the if you decrease the load resistance, then current will be increases like that. Same thing V by IR. You know about your houses. If you switch on the your circuited like a fan is okay. If you increase the bulb, you switch on the bulb, another bulb, then there is a load is increases. Then at that time overall resistance will be reduced because of the number of all operators are connected in series, sorry, parallel only, parallel connections like that. There are some voltages, there are overall current, there are switches. Suppose this one is the bulb V1, sorry, V1, bulb V2, bulb V3. If you switch on this one, bulb V1 is glowing, and sorry, this current will be flowing to main current I1, I2, and I3. If you switch on this one, the all operators are connected in parallel only in houses. Then if you increase the load, it means if you switch on the any load, then both are connected in parallel. At that condition, overall resistance will be decreases, then current will be increases. Then when you switch on the bulb, it means the load will increases. Load increases means load resistance will be decreases, like that. If you switch on this one, then another current also flowing this one, the overall current will be increases, then but overall resistance will be decreases. Same thing here also. Sorry. Same thing here also. This is the RL. When RL is equal to infinity, this is the point, RL will be 0. Then RL will be decreasing. If you decreasing the RL, it means load resistance, it means load will be increases, current will increases. If you increase the load, then this point will happen at some time here. Suppose this is the load line, a load resistance here. At that point, the same, if you take this one is the V1, this is the V2, then overall is the V1 plus V2. At this point, V1 plus V2 total voltages. But what happened current? Same thing, current it can be delivered, both are can deliver, both are delivered the same current rating, because of this is the current rating here. This current rating is the our current requirement or our load requirement here only. Then both can deliver the that current. So this current. Suppose if you next we increase the current rating or increase the load there, then what happens at some time it will reach that point here maybe. Then this current rating is fully zero. Sorry, voltages. At that point, what happened? V1 plus V2 both are connected in series. Then V1 plus V2, okay. Okay, this will not happen. This will be okay like that. It will go like that only. Why it will go like that? I will explain. If your load line is this one, it means if you increase the load more, current will be increases. At that point, what is the V1? V1 will be 0 because of at this point V1 will be this one only at this current point. V1 will be 0. Yeah, you can say this is just if you measure some current is there, if you increase the here only, then this will be a 0. And this is the V2. This one will be V2. Then if this one is the 0, V1 will be 0 because of the this one, V1 cannot be delivered the that current. both are sources connected in series only, then it should be both current source deliver the same current. If there is not delivering any on sources are not delivered that much current, it means that sources works like a sink only. That's why this is the voltage is zero because of this I1 cell 1 is cannot be delivered that much current because of you know about the IV characteristic of VOC ISC. This will be a voltage current. Any cell can be deliver only the ISC current. It can't be deliver the more than ISC current. But ISC current at which condition? In short circuit condition. It means the voltage it can't be delivered the voltage. Voltage will be zero at that point. That point it can deliver the short circuit current. Rating of short circuit current. Same thing here. It can be delivered that much current only when the voltage that voltage will be zero. It means V2 will be zero at that point. This is the zero voltage. This is the phi. Then what is the overall voltage? This voltage is zero. Then what is the that point? Voltage Vt is only V1 because of V2 is V0. Then only V1 is delivered the voltages only. This RL load voltage overall voltage will be equal to V1 only. This voltage. This will be a zero voltage. Then what happen if you increase the load more than this one? Suppose I increase the load line of this one to here somewhere like that. I remove this one to visualize all of them. There is a load line. This much current is flowing. Then this current is this one. Then what happen is cell 1. It will be zero here only. But I increase the load more. And that condition current delivering current is zero. Voltage is zero. It means it's at that time a polar resistance of the cells are working like a sink, and that provided the negative voltage because of the any resistance. If you suppose any resistance is there, if current flowing through it, then the entering point is positive or leaving point is negative. That it means that this resistance is working like a sink. Same thing, at that point this will be a positive terminal, this will be a negative terminal because of current is entering in positive terminal. That point that system is known as the passive system, or is this is working like a sink. If you current leaving from positive, then this will be work like a source only. If you current entering from positive, then that circuit known as the passive circuit, or this system sources is the this is the not sources, this is the sink only. That's why this will current will be sorry V2. I think it is, I provided this other thing. This was the V2, this was V1. Then V1 will be a negative term. Negative goes to negative. Why negative? Suppose understand from here. Suppose if you go, I provide the maximum current rating. Yes. At that point, what happened? Overall voltage will be zero. Overall voltage zero. Current will be maximum ISC2, maximum short circuit current of cell 2. This is the overall voltage only to both this one. At that condition, you know V2 is equal to V1 only. Then there will be a source. If you will go to the source circuit here, then what happened? If you take same thing like plus minus V1 and apply the KVL here, minus V1 minus of V2 is equal to 0. And what happened? V2 is equal to minus of V1. It means the same voltages are applying will be negative. V1 and V2 will be totally negative at that condition. In that condition, overall voltage will be 0. And this will be 0 where that there is some positive voltage V1, sorry V2, V2, V1 is this should be negative voltage. At that point, it will be 0. Then this is the current graph of this one, IC1. Then IC1 work like a source, and this voltage will be a negative of V1 voltage. This voltage minus of V1, same equal to V2, the maximum current rating, and the overall this will be overall will be like that. Block curve working like that only. At a 0 point, the V1 is a something here. This is the sorry. This is the V2 line. I remove all of thing. Thing all confused on this one. Okay. This is the V2 and this is the V1, and V1 will be a minus of V2 equal to minus of V2. That time the overall current will be overall voltage will be 0 of this circuit. This one. Then what is the negative? It's negative current flowing. Current flowing in the same direction. Current will not change the direction, but voltage will be negative. That means P is equal to V into Y minus of V into Y. This means the power will be a negative. For the source, power will be negative. It means the source will act like a sink. That's why there is the power taking from this one. Then how you protect them? It means this will be the negative, this will be the positive. Correct. Positive, negative, V2, V1, this will be current flowing through it. This will work like a sink. This will be a source. And how protect them? This type of condition. If
to
you
provide a diode.
yes, to provide a diode to bypass this current like this. Same to cell, if we provide a pilot to the a diode to bypass the current. The same thing. If your current is not flowing through the cells, then cell will be not acting like a sink. Cell will be isolated. Then current is flowing like that. Current is flowing like that. But in practical cases, this if a diode is the ideal cases, then current will be 0 here only. Negative voltage is not there. But practical cases, diode have some forward voltage drop also. You know about the PN junction diode. There is some voltage drop like a zero point 0.6 volt, 0.7 volt, zero point 0.7 volt for the silicon diode. Then there is some negative voltage also there. This will be a this voltage will be a minus 0.7 volt only. But there is a very less voltages. if you connect it like that only, then the whole all of the current is flowing through the diode and working. If many of the cells are connected in series, then you can provide the this type of diode to protect them from going to power negative or working like a sink. This will happen when this is the series connected. Same thing will happen in parallel also. Okay, let's take a question in series connected. Same thing, there is a current source, cell 1, cell 2, anti-parallel diode, and this is the shunt resistance. In practical cases, the shunt resistance work like a sink when there is a some side of. The two solar PV cells are connected in series across the current source I naught. I naught greater than 0, it means this is the positive current and direction will be here, this direction. As shown in figure, the modules of both PV cell are simplified by neglecting the effect of series resistance. Series resistance is not there here, only shunt resistance is there. The condition for either of each cell to not dissipate power is given by. It means the any of two it not working like a sink. Then what is the condition of that condition? Both are work like a source only. The both are work like a source only. It should be a both are the same current rating. But this is denoted the RL load line. Load line is the I naught current. Suppose I1 is equal to I naught, but I2 is not equal to I naught, or it will be less than I naught. Then what happen? Then cell 2 work like a sink, will work like a sink at that condition. But what happen if I2 greater than I naught? Then something current is flowing I1, then I1 I2 both are delivered the current, then there is no problem. ISC1, ISC2, then VOC1, VOC2, C2. There are many options. Suppose I1 is greater than or equal to I naught. It means I1 is greater than or equal to I naught. So it means I naught is here something. It may be here. Load line is maybe here or here. Maximum current is here or equal to or greater than I1. I1 should be greater than. It means the load line is between them. Then what happened? Both are delivering the current, delivering the power. There is no problem. But it's not mentioning the I2 current. Then it may be I2 less than I naught or maybe greater than I naught. Then you can't be choose this option because of I it's not provided information about the I2. Same thing here, I2 is greater than or equal to I naught. Okay, I2 is greater than I naught, but it's not mentioning the what happened in IC1. Yeah, I1. It may be here also, load line may be here also, and that condition I1 is cell 1 working like a sink because of the this current is more than the this current. Not provided any information about the I2, I1, that's why this will be also wrong. Third one is I1 greater than or equal to I naught and I2 also greater than or equal to I naught. It means here load line working like here only. Both are delivering the more than the I naught current. It having the more than the current of load current. Then there is no problem. Both are working like a source only. It may be correct. Sorry, it will be correct. Then what is the last option? I1 greater than or equal to I naught or I2 greater than or equal to naught. then there is still a problem. If suppose I1 is greater than I naught, I mean I, then load line may be here only between them. Then I1 is working like a sink. Same thing if you opposite of this one ISC1, suppose this was the I1, this was the I2, and same thing here. Then I2 working like a sink, I1 like a source. To me, that's why it not OR option. Only end option is there. So which one provide the all time? Both are working like a source only. The condition either of each cell are to dissipate the power. The soul not dissipate the power. Not dissipate the power. It means both are anyone not working like a sink. That's why option C is correct. Same thing, what can be done to the circuit shown in figure of question, same question, to prevent the power dissipation in the either of cells? To prevent the power, same thing, a diode, the put the bypass diode in parallel across cell 1. If you provide cell 1, then maybe cell 2 is working like a sink. Is a diode across the CS2, the cell 1 maybe work like a sink. Then what can we say? Put the bypass diode in parallel across cell 1 or cell 1? No, both. But put the bypass diode in parallel across each cell. Then you can prevent this one. To prevent the dissipation of power. If you provide any one, then there is not mentioning anything about the cells. Then it may be cell 1 is working like a sink, or maybe cell 2 working like a sink. That's why. A photovoltaic panels has three modules connected in series. Each module having an open circuit voltage of 10 volt and short circuit current of 2 ampere. Then what should be the VOC and ISU for the series combination? Three cells are connected in series. Each module having open circuit voltage of 10 volt. This will be a 10 volt. This will be a 10 volt. This will be 10 volt. Short circuit current of 2 ampere of each. Or then overall voltage V same thing. Series connected 30 volt. Current will be same 2 ampere only. Yeah, this is the easy question. I think. They are not providing anything about this partial shading like that. That's why you can take identical only. Mentioning also each model has open circuit voltage at 10 volt. I saw so too. Okay, that's why. A question: a PV module with a 20 cells connected in series has an idealized rectangular IV characteristic with VOC of 20 volt and ISC of 2 ampere. Then each cell having negligible series resistances and shunt resistances of 10 ohms. Then if one cell is completely shaded, then the IV characteristic of the entire the module looks like. This is the VOC, this one is the ISC. This is IV characteristic in practical cases when the shunt resistance and series resistance also there. If both are negligible, then this will be looks like a parallel only. Oh, so like rectangular. This is the ideal cases. Red one. In ideal cases, this will looks like a rectangle only. VOC and IOC. This will be the practical cases. Here is mentioning the idealized rectangular IP characteristic. It means there is a 20B like that. 20 volt and current will be a 2 ampere. This is the IV characteristic is given for the 20 cells are, because of 20 cells are connected in series and having the idealized rectangular voltage IV characteristic, the VOC is 20 volt. For the 20 cell have a open circuit voltage of 20 volt. Then what is the each cell voltages? Because of the series connected, then 20 into VOC1 is equal to 20 volt. 20 cells are connected in series, then VOC of one cell is 1 volt. Okay, fine. Current rating, each having a 2 ampere of current rating but connected in series, then overall current rating is 2 ampere only. ISC also 2 ampere of each cell, and have connected all the cell in series, then also 2 ampere current rating. Okay, then next is saying then there is the negligible series resistances, but there is shunt resistance is there. It means this will be looks like this one only. There is a cell, one cell, same cell connected in series like that. This will provide the 10 ohm. If one cell is completely shaded, it means current will be 0 and voltage will be 0. Then IV characteristic, asking about the IV characteristic. The voltage is 0, that what happened in the overall voltage? There is 19 cell only. If one cell is completely shaded, connected in series, one cell have a 1 volt, then overall voltage VOC is 19 volt, 20 minus 1. But what is the current rating in short circuit condition? Suppose I mentioning like that, for the easy way, I connected a cell like this one. This will be 1, 2, same thing, 20 overall voltage and overall current. If all the ideal cases, then all of the voltage is connected in series, then overall voltage is 20 volt, and current is all the provide the same current rating at 2 ampere, then overall current is 2 ampere. In the ideal cases, characteristic like that only. This will have 20 volt, this will be 2 ampere. But one cell is solely fully shaded. This will be out of the picture. This voltage is 1 volt, this voltage is 0 volt, this voltage is 1 volt, something like that. Then overall voltage will be 19 volt, because 1 volt is 0, all of these 19 volt. But current is flowing like that in the setting, partial setting or fully setting. Current in that condition, current is flowing through the shunt resistor, then that cells acting like a sink. Previous cases I told about that. Then then this is the passing through the all of the voltage is there, but here only resistance is counted only. This resistance will be a 10 ohm. Voltage is 0, but resistance will 10 ohm. Then this 10 ohm resistance work like a load, working like a load, yeah, like a sink. In this condition, then what happened, this will be short circuited. Then what is the current? IV, in IV characteristic, this is the open circuit VOC, and this is the ISC. If this is the short circuited, then what is the current? Current will be know about V by R only. Then what is the total voltage? Total voltage is 19 volt. And resistance, this shunt resistance working like a sink only, like a load, then this will be the 10 ohm resistance. And overall current will be a 1.9 ampere. It will be a 1.9 ampere can deliver maximum current rating. Because of this one only. The whole of, because of some of the voltage drop across it. The voltage drop across it, that means the overall voltage will be 19 volt, sorry, and the overall resistance when short circuited, there is a not zero resistances. If there is a provided this is working like a source, then this is the zero resistance, provided the zero resistance or the load, then overall short circuited is the current will be maximum and resistance will be zero. But in this condition, there is a providing the source a sink, resistance is there 10 ohm, then overall current flowing through it will be 1.9 ampere only in short circuit condition. Then we got 2 point V I will be 1.9 ampere, this will be a VOC even 19 volt. Then what is the curve of this one? It will be like that, sorry, or like that.
Second one.
Like that. Why second one? Because of this, all of this the source. Suppose if you working like a source, a voltage source, 1 volt, 1 volt, 1 volt, but there is a resistance. Then this is resistance working like a voltage source and a series resistance. If any circuit, I have some voltages and a series resistance, then this resistance is a linear resistance, provide the some RS B. Then if you find the terminal voltage characteristic, it will be a like that only. This is open circuit voltage V only. This is current, short circuit current I. But if you increase the load resistance, decrease the load resistance, provide the load resistance, and increase the current will be flowing like that only. Same thing here. All of the working like a source, but one of the cell is working like a sink. That's why the overall voltage, overall the characteristic will be flowing, showing like a voltage source and a series connected of them. That's why the overall characteristic is second one, this one. Maximum short circuit current is 1.9 ampere and open circuit voltage is 19 volt, and graph is this one waveform. I think this one is the current, or another option is given as the same thing here, but is the 2 ampere current rating. But you know about this will not flow the full rating of current. If the two cells are connected in series, suppose 2 is there only, then if you I1, I2, then you can't be provide full current rating of anyone. This is just some little bit, because of it, between them only the negative voltage applied on first one, so minus V1, so plus V2, V1 plus V2. If you this will be equal any time, any point of time, that point is the short circuit current only. Because of overall voltage will be zero, voltage zero, it means short circuited. then it never goes to a I2, a maximum current rating. That's why this will not correct. This will 1.9 ampere only. Same thing referring the question number 4, previous question, what the current would the module deliver to the 10-volt battery connected across it. Same thing, this will be looks like a voltage source and a series resistance. There is a 10-volt of battery is there. This is 19-volt, 10 ohm. This is a 10-volt battery. Then what is the current? So you can easily find current is the 19 minus 10 divided by of 10 at 0.9 ampere. Because of this whole circuit is working like a voltage source and a series resistance of 10 ohm. Same question, what is the power delivered to the battery? Same, I think P will be I. Battery voltage only because of the power delivered to the battery, not power delivered to by the sources, all the PV cells. It asking about the power delivered to the battery. That means this battery voltage and that current. BV battery is 10 ampere, 0.9 ampere current is there, then 19 watt. Okay. Two dissimilar PV cells are connected in parallel. No protection diode are there incorporated. Let the open circuit voltage and short circuit current of the one cells be a 10 volt and 2 ampere respectively. Let the open circuit voltage and short circuit current of the other cell be a 12 volt and 3 ampere respectively. If the VOC and ISC represent the open circuit voltage and short circuit current of parallel cell combination, then what is the operating voltage limit? What is the open circuit voltage limit? Same thing you can say in series connected, two cells are connected in series. Right there. Same thing here. If you two connect non-identical cell are connected in series, then what is the voltage? Sorry, current rating is current rating between them only. Short circuit current rating. Sorry, short circuit is current is the middle of this one only. I1 to I1. Maybe any between them. Same thing in parallel connection. The open circuit voltage are between them only. V1 to V2, VOC 1 to VOC 2. Sorry. Same thing, to take a 2 so plus minus V1 plus minus of V2. Current I1, sorry, current I2, I1. Both are quite the current. Current will be add up in I section. I is equal to I1 plus I2 anytime. Same thing in series is VOC, V is equal to V1 plus V2. But what happen in voltages? Voltage different. If V2 is greater than V1, then what happen? There are circulating current is flowing through it. If V1, V2 is greater than V1, because this is the practical case, since current is flowing like that only. If a V1 is greater than V2, the current flowing like that only, and this will be acting like a sink. This is the source at that time. If both are same, V1 is equal to V2, then both are deliver the power. Same thing, suppose this was the V1, V2, ISC1 and ISC2, and what is the circuit overall view V and I, same thing, double of this one current rating, and voltage is same. because of the identical cases. ISC is equal to ISC1 plus ISC2. This is the identical. These are both are same. But what happened if there is a not identical, and a protection diode is also not there. Then what happened? VOC1, this will be ISC1. Okay, second one VOC2, ISC2. In parallel connection, suppose we start at 0, the maximum current rating. What happens? Voltage is 0, the voltage is 0, then both are current is added and short circuit condition, both are delivered because of the voltage 0, then 0 voltage provided by them both, provided by the both. Then what happened? This is the overall current. ISC is equal to ISC1 plus ISC2. Sorry. What happens if we increase this one? Current is decreases, voltage will be increases like that. At any point a bit middle of this one, then voltage will be same because of the both sources can deliver the same voltages. Then overall voltage will be a V1 plus V2 at that point, and current is same current rating I1 plus I2. What happens is there at that point we also same voltage delivery because of the voltage delivery here. Voltage can be delivered here from through here also. Both are the same. There is no problem. But what happens? This will be a 0, and there is a some voltages at any point. This will be looks like that. At this point, suppose V1 will be 0. V1 will be 0 voltage, and V2 have some voltages. Then what happens? This one. This will be the V2. V2 will happen because of the sum of resistances is there, a shunt resistance. Then voltage is dropping there. That's why voltage is delivering here only. If you load decrease more than this one, when it decreases, means current will be decreases, then voltage will be increases. Then what happened? If you goes beyond to this one, sorry, this is not a V1 plus V2. V1 is equal to V2 because of here you can see at that point V1 is equal to V2 only. Sorry for that. Current will be increases, voltage will be same. V1 is equal to V2 because of both can deliver the same voltages at that point. At point here also from here till here, but at here the one voltage is zero, totally zero. but other will be can be deliver the voltages. Then what happened? It will deliver the voltages, some voltages, it not exactly same V2. It deliver the voltages, deliver the power till the this voltage will be 0. And in what cases this voltage will be 0? In that cases, the whole power delivered by them will be here only. V2 is equal to V1. In that condition, overall voltage will be 0. Yeah, same thing you can say this will be 0. This voltage will be 0. Current. If this current is totally flowing to negative of this one, then current will be 0. Voltage will not be 0 in that cases. Polar cases, there are some voltages, but current will be 0 maybe. Because of there is some voltages from here. Sorry, this is the not a 0 voltages. I forgot this one. It can't be 0 voltages because of this the parallel connection. Current will be 0 here. You can see, sorry for them. This is the some voltages V1 only. This is the V1 voltage, but current will be 0 here. This current will be 0 this point. I forgot of this one, sorry for them. This will be 0 voltages. Sorry, 0 current. At that condition, you can see the overall voltage is V1 only. And you can say V2 also same at that point because of the V2 can be say can be that voltages. But V1 has a maximum voltage of this one. V1 have a maximum voltage of this one. V1 maximum voltage is this one. You can say this will is the VOC 1 only. But at that point current will be 0. In this condition, cell 1 does not provide any voltage, any current to the circuit. It will be 0 voltage, but it's not taking any current also. You can say this will be the isolated at that point. The whole current is delivered by the I2 only. Whole current delivered by the I2 only. I1 will be 0 and V1 have a I1 will be 0. It means what happened? V1 have a open circuited. Cell 1 have a open circuited. That means na if a current is 0, it means V1 have a open circuit. Then this is the open circuit voltage. Open circuit voltage, same voltage appear on the terminal of the whole combination. But what happens if you decrease the load more than this one? To decrease the load more than this one, load line is going through it, then this will be taking a negative current from the I2. This will current taking a negative current. Here you can see to V1. If you decrease the current rating more, then this will deliver the current rating through this one and this one both at that condition. Then I1 will be negative. It means cell 2 taken current from the cell 2. Cell 1 is taken the current from the cell 2. Then overall current is be I2 minus something I1. At this point, this is goes like that. Then okay, if we increase this one, if we touch the here, if we increase more current, then this will be going to the negative. here this negative of current is equal to the this negative of current. This will be I2, I1. I1 goes to negative. If the current sourcing that much current is taking from the I1, it means I2 is equal to minus of I1. Then overall current will be 0 because of the I is equal to I1 plus I2. But here the all of the current taken from the I1 only. Then overall current will be 0. Then overall current will be 0. It means this circuit works like a open circuit. Then that voltage is the open circuit voltage. Then open circuit voltage is between VOC C1 and VOC 2 only between them, because at that point the how much current delivering from cell 2, same current is taken from cell 1 only. Then overall current will be 0 at the terminal of the combination of parallel connection. That's why this which current is taken from this one. Then there is some voltages is here, and this is the current is there. Then some power losses at cell 1. It means cell 1 is working like a sink at that condition. Same thing, if you want to protect them, then simply you can add a diode series of this one. If you are diode connected, then what happened? This current is never goes to this one like that. This current always flowing through it. This one also flowing through it. It will never go to like that because of the diode. And that condition, same phenomena. But when this will be 0, then that I1 current is 0. I1 is isolated from the circuit. The whole of the current is provided from the cell 2 only. I can draw a circuit when protection is provided. VOC1, ISC1, at a starting maximum current is flowing. ISC is equal to ISC1 plus ISC2. When this voltage is 0, it goes to 0, then this will be follow that path only, V2. Because of the V1 is isolated from the circuit of the combination because of the diode connected in series, then no one current flowing through it. The whole current is flowing through the combination of the terminal only, I from the cell 2. That's why this will be a graph from for the parallel connection. Same thing is series connection. I think if diode is there, then overall voltage, overall combination is current from VOC is equal to VOC1 plus VOC2 is flowing like that. When current is 0, this will be isolated from them. Then this will be the overall characteristic when diode is provided. Then cell 2 is working. Only cell 1 will be isolated from the circuit. Then what is the circuit? Uh, asking about the what is the open circuit voltages? I think. Then open circuit voltages is between the 10 volt to 12 volt. because of this there is not a diode provided series with the cells. That's why if a diode is provided a series with the cells, then the maximum voltage is appearing on the terminal of the combination. Then 12 volt, there is a 12 volt, but there is not a diode, then this will be the between them. Terminal voltage is between the low cell to the high cell voltage. Similar to these similar PV cells are connected in parallel. No protection diode as the incorporated. Let the open circuit voltage and short circuit current of one cell is 10 volt and 2 ampere respectively. And let the open circuit voltage and short circuit current of the other cell is 12 volt and 3 ampere respectively. The VOC and ISC represent the open circuit voltage and short circuit current of the parallel combination. Then the short circuit current. Short circuit current is the sum of the both current 3 ampere 2 ampere. Then there is no issue. Because of short circuit is here, at this condition voltage 0, then both the cells can be provide that voltage, and overall voltage is a double of this one, sum of this one, ISC1 plus ISC2. This will be a 5 ampere only. A few photovoltaic modules are connected in series parallel configuration, so in the figure below. Each module have a IV characteristic having a x-axis intercept of 31 volt and y-axis intercept at the 4.2 ampere. In the short circuit current, open circuit voltage of the series parallel systems shown respectively. 31 volt, this will be 31 volt, this will be 31 volt, this will be also 31 volt. And what is the overall voltage? And current is 4.2 ampere. Same to all. What is the current rating? Current rating is a double of this one. Then 4.2 into 2, 8.4 ampere. Voltage rating, series of this one, 31 into 3, it will be a 93 volt. Because of the parallel connection, both are same voltages appears. That's why this one. Battery having a voltage of 48 volt is in series with a 10 ohm resistance. Okay. There is a voltage battery of 48 volt at series resistance of 10 ohm. The internal resistance Rs is equal to 10 ohm. Because terminal of this system, a load resistance is connected. A RL is connected here. The maximum power that can be transferred to the load resistance. Same thing you can say in PV cell also. There is a PV cell in which is series resistances. The what is the maximum power transfer from them to the any load? Can you take a current? Current is suppose I. Maximum current is I. Then what is the I current? V divided by of Rs plus RL. What is the power? Power is equal to this voltages, or you can see I square into RL. This is the power. Then what is the I? I is equal to V divided by F Rs plus RL square. It asking about the maximum power transfer. Then what condition is maximum power transfer? You know about in mathematics, maximum power for the any quantity. If you want the maximum and maxima and minima, then you differentiate that with respect to the any point which one you want to know. Then you should differentiate this one power with respect to the RL because of I have not value of RL. This one you can say VY square into RL divided by of RS plus RL whole square. V is the voltage. Voltage is a constant. 48 volt is given, and RS are also constant. Then you can leave it in common. This one d differentiate with this one is equal to V square or differentiation of any two quantity like uh, numerator and denominator. Like the first denominator and differentiation of numerator. Numerator is the RL only. RL respect to the RL will be 1 minus numerator and the differentiation of denominator. If you differentiate this one RS plus RL whole square with respect to RL, then you will find 2 into RS plus RL. Again we want to differentiate of this one RS plus RL, then RS will be 0 because of the constant, then RL is be 1. And denominator whole square of denominator will be 4. For P maximum, to find maximum power, dP division of d RL will be 0. At this condition, this will be 0, this will be common, Q square, this one will be 0. And you can say RS plus RL whole square minus of 2 RL into RS minus of 2 RL square. 0 is equal to this one will be RS square plus RL square plus 2 RS into RL minus of 2 RL into RS minus of 2 RL square. Now this will be cancelled out. RL square minus 2 RL square, so what is the RL is equal to RS. It means also know about the maximum power theorem, maximum power transfer theorem. The source load resistance should be equal to the load resistance should be equal to the source resistance. That can that condition you can transfer the maximum power from source to the load resistance. But it is a condition variable resistance should be a load resistance, not a source resistance. If the source resistance is variable, and that condition source resistance will be 0 only. At a 0 source resistance we can transfer the maximum power if the source resistance is varies. But here is the load resistance is vary because of the load resistance is not given. Then you have to choose the load resistance. At that condition you can transfer the maximum power. Same thing this can be happen in PV panel or PV source also. You know about the maximum power point tracking. Same phenomena also there. You have to match the PV panel resistances to the load resistance by providing some converter like a buck converter, boost converter, like that, to provide a duty cycle at that adjusting the by the duty cycle at which point the source resistance equal to the load resistance at which duty cycle. Same thing, maximum power transfer is applying there also. This is the RL is equal to RS. It means this will be a 10 ohm. Then what is the maximum power? Maximum power is this one. I is equal to 10 ohm. 10 plus 10 divided by 48 divided by 10 plus 10. Then I is equal to 2.4 ampere. And what is the power? 2.4 square into 10. it will be 57.6 watt. So next was given as a PV panel having an area of 1.5 meter square gives the following reading under the standard test condition. Standard test condition, it means insulation of 1000 watt per meter square and temperature is will be 25 degrees centigrade. The short circuit current is 8 ampere. The open circuit voltage is 40 volt. The voltage at a peak power, it means VMP, is well 36.5 volt. Current at peak power, IMP, is equal to 7 ampere. The fill factor of the PV panel is found to be 0.72, the efficiency of the panel. What you know about the efficiency? P output divided by a P in. P output is given the maximum power 36.5 into 7. P in, P in is the insulation into area. Insulation is given 1000 watt because of the standard condition is given. Watt per meter square, area is 1.5 meter square. Then you can calculate efficiency. 36 into 7, 36.5 into 7, 225, 255.5 divided by a 1500. It will be 17%, 0.17, or in percentage will be 70% efficiency. Okay, fine. Same thing, a PV panel is tested under the standard condition. Same question. The short circuit current is 8 ampere, open circuit voltage is 40 volt. The voltage at peak power is 36.5, and the current at a peak power is 7 ampere. And the fill factor of the PV panel is found to be 0.72. The incident input power on the panel is 1800 watt. The area of the panel, no need to anything. P in is equal to insulation into area. Insulation is given as a standard condition, it's in the 1000 watt per meter square. P in is given 1800 watt. And what is the area? 1800 divided by a 1000, it will be 1.8 meter square. Okay, fine. Two identical PV models are connected in parallel as shown in the figure below. Voltage and current is corresponding to the maximum power per module or 28 volt and 3.2 ampere respectively. What is the value of load resistance in ohm for the same insulation and temperature? Same insulation, it means a standard condition, I think, in place of this one. What happened in maximum power condition? Previously, we draw the RS is equal to RL is load is equal to RS, source resistance. And how we will find the source resistance of this whole circuit? But you should find this one, the source resistance. Then after you can say the source resistance is equal to the load resistance at maximum power transfer. It is given as the maximum power module per module is 28 volt and 3.2 ampere. This will be a Pmax is the 28 volt. This will also 28 volt. This current will be 3.2 ampere. This current is also 3.3.2 ampere. Then this will have some internal resistances. You know about the series and parallel combination. Then I talk about the parallel combination, whole combination. I have some resistances. This is also have some resistances. Then what is that resistance is maximum power at maximum power condition. Maximum power transfer condition is given at maximum power condition is given at 28 by. Then what is the resistance of R1? This one 28 divided by of 3.2 ampere. This will be equal to the R2 also because of the both are the same. This will be a 8.75 ohm. Then you know both are connected in parallel. Then you can say this will be a resistance like that. Then what will be the equivalent resistance of this one? Then equivalent resistance, you know about the find the Thevenin equivalent resistance. If you want to find any circuit for the any circuit to have a Thevenin, or if you want to find Thevenin equivalent resistance, then you should remove this load and looks like that. This will be V and some current is I. That will provide the V by I, that provide the internal resistance of this one, the whole circuit. Same thing. Neither you can't be say that what is the internal resistance of the whole combination. Suppose if there is a many resistances are there and many voltages are there. There is some RL, R1, R2, R3 plus minus V2, R4, R5 and V1. Suppose someone asks about the what is the value of RL for maximum power transfer. Then how will you find? In that condition, because of you require of this one, the whole circuit parameter, what is the whole resistances of this one, then you can be easily solve of this one by a Thevenin theorem. Thevenin says that the number of sources and resistances are there, then you can be converted as this one a single source and a single series resistance, and this resistance equal to the load resistance at the time of maximum power transfer. And how you can find the Thevenin resistances? And Thevenin says that remove this one and find that voltages and that current at this position. You find this one, the V by I, you can find this will be the R. Or you can find this will equivalent resistance of this one by remove the sources. Like if the voltage sources, then you can short circuit of this one. If there are any current sources, then you can open that terminal or that branches. Then you can find the total resistance. There is a parallel of this one. You can solve easily. After that, you can series add this one. Then there is a parallel of combination. Then you can add the RL. Finally, you get the RT. RT same as the series resistance of this one. RS. Then RS equal to RL. Sorry, RL is equal to RS for the maximum power transfer. Same thing I'll do same thing from here for the here also. There is a one resistance 8.75 here and 8.75 here. Then what is the total resistance? RT is the parallel combination of this one. R1 parallel to R2, same thing, 8.75 divided by F2 because of the same resistances. Then RT is equal to total resistance is 8.75 divided by F2 is will be 4.375 ohm. Then what is the RL? RL is equal to RS, RT, it will be a 4.375 for the maximum power transfer at this condition. Both load are connected in series. The same thing we can apply a Thevenin equivalent to find the series resistance or find the load resistance. Okay. What is the load resistance when two unidentical PV module are connected in parallel, whose PV voltage is 25 volt when delivering the power at different current values as mentioned in the graph. It is asking about the load line. Load line vary from there to here. This will be R load line. It will be a delta I divided by a delta B. This is voltage graph, voltage axis. This is the current axis. It will vary like that. This will be here is the RL is equal to NPT. Here RL is equal to 0. Something it will vary from here to here. But is asking at that point. RL. What is the RL of that point? In a parallel condition, two unidentical modules are connected in parallel. What is the voltage? I. You can see the RL is equal to V by I. Same thing. If you find the voltage and current, then you can get the RL. This is the 4 ampere. This is the 7 ampere. Looks here. The maximum voltage can be delivered is not given. This is the VOC 1. This is the VOC 2. But it is given the operating point of operating voltage. Then operating voltage 25 volt. And 25 volt is below of both the line. It means 25 is less than the all the VOC 1 and VOC 2. Then it means the both can deliver that voltages. There is no problem. Then what is the current rating? Then current simply adding up this one. If the rating of this one is suppose VOC1, VOC2 is suppose this will be the 50 amp volt, this will be 40 volt, but operating voltage is only 25 volt. Then what happens? Both can deliver the power. The both how much deliver the power? Both can deliver the at a full current rating. Which one is given here? This is the full current rating of at that point. The 4 ampere and 7 ampere. What is the overall current? Because of the parallel connection, then I1 plus I2 it will be 11 ampere, and voltage is also given. Overall voltage is 25 volt. Then this will be 25 volt. This will be 11 ampere. So what is the RL? V by I 25 by 11 is equal to 2.27 ohm. Yeah, that is simple. Next is given as the circuit IV characteristic for the two PV models as shown below. Above the what load current does one of the PV module contribute negative power? In series connection, there is the mismatching of the current. In parallel connection, mismatching of the voltages can contribute the negative power of any one cell. And here is asking what is the current rating of the load current. Load current, it means the load can vary current from here to here. A current is be load vary from here to here, or else maximum current rating is this one, maximum voltage is this one. Then asking about the what at what current load current the any one modules contribute the negative power. Okay, let's test about that by point to point. Suppose our current rating is this one, then what happened? Both model can deliver that current rating. This one, if you increase this one like that to here, this is also suppose this will the 5 ampere, because this one is the 6, this is the 9. The 5 ampere current can deliver from the both module. There is no problem because of here. This point is here only. If you increase this one at 6 ampere, then what happened? This is the maximum current rating of the cell 1 only. That can be delivered at 0 voltage. This is a 0 voltage, this is the V1. If you take as V2, that overall voltage is V1, V2 only. This is the V2 voltage. This voltage is the overall operating voltage. This point, the operating voltages that can deliver. If you increase the load line beyond the 6 ampere, this is the 6 ampere line. If you increase the load line beyond to this one, suppose here, okay, anywhere, and that condition this will provide the negative power, because of the this is the current will be negative current flowing through the load parallel resistances. That's why this will be provide the negative power. Negative power, it means this will work like a sink. First one, when it work like a sink, when you exceed the current rating from 6 ampere, if the load is greater than the 6 ampere, then what is the maximum point rating is 6 ampere only. To increase this one, then this will be deliver the negative power to the load or the system. Okay, the next one is asking about the in the circuit shown in question number the previous question, which is the best method from the following option to eliminate the negative power contribution by the module. Same thing, we provide the diode, but in what manner is given in the option. Put a diode in series to each module. Series of each module, it means provide diode here, one diode here, and diode. It can be protect, it can't be protect because of current is flowing like that. There is no meaning of this one. This can be meaning in parallel connection, not a series connection. Second one, put a diode in parallel to each PV module in such that cathode and anode terminal of diode are connected to positive and negative terminal of PV module. This means this is the positive terminal, this is the negative terminal. It asking about the cathode, a diode. Here is the anode, here is the cathode. Anode is connected to the negative terminal, cathode is connected to the positive terminal. It's given like that. The cathode and anode terminal at diode are connected to positive and negative terminals. So positive terminal is the cathode and negative terminal to the anode. Parallel to this, like that. This is the So this is the anode, this is the cathode, cathode to the positive terminal, anode to the negative terminal. Same thing happens here also, anode, cathode. Yeah, this is the best solution. Current flowing like that. If this one is the working like a sink, and if this one working like a sink, then this will be current flow like that. And neither this will current flow like that, and this is current is like that to provide the negative current, negative power protection. Then what is the next? Next option is to put diode in parallel to each PV module such that the anode and cathode terminals of diode are connected to positive and negative terminal. It means anode is connected to the positive and cathode connected to the negative. Next question is option is given to connect like that. Anode connected to the positive, cathode connected to the negative. Suppose if you connect this one like that, then what happens? In this condition, if the PV module high voltage is greater than this voltage is high greater than this diode breaking voltage, blocking voltage BBU, then what happens? The all of the current is flowing like that. Then you can't be connect the diode like that. That's why this is not option correct. Put a diode in series to one of the PV module and another diode in parallel to the rest of the module. Put a diode in series to one of the PV module and another diode in parallel to the rest of the PV module. Is asking like that. One is the series, another have a parallel diode. Then what happen? All sorry, another all of the PV module are protected from the diode, but one of the module is not protected diode. If this one is the have any partial shading, at that condition this PV module work like a sink only. That's why you can't be provide this one also. The best solution only when you can provide this one like that. This is the, if this is the positive terminal, negative terminal, this will be the reverse bias condition. Sorry, this is also reverse bias condition. Then when this will be a forward bias condition, in such a way, if there is some voltage is 0, then this will voltage 0. At that condition, this is also not forward bias because of the diode have some internal voltage drop or blocking voltage capability. If blocking some voltages, if that voltages, if you increase that current here, you want to this one from the 6 ampere, then what happens? This will be provide the negative voltage. It means this will be a provide the negative voltage, then this will be a negative, and this is the positive, opposite of this one. And that condition, these voltages will be a forward bias. Will do the forward bias of the diode because of diode appears at the positive voltages appear in anode and negative voltages at the cathode, and diode will be in forward bias condition, and that condition this will be working like a short circuit, and this will be current flowing like that and protect the this PV cell from the negative power supply and increase the efficiency. Then you can say if you have a string of number of series and parallel combination, then in parallel combination there is only one diode is there in top of the diode. You have like that, And this is the overall voltage, overall current. The large number of series and parallel connection of a PV module, then you can protect them by providing the a series and parallel diode. There is only one parallel series diode, the requirement of in string in connected in series. But in parallel connection, sorry, in series connection, there is a all of the all of the model are connected a diode to protect them, like that. But if you talk about the large number of panel, then there is some grouping. Some of the modules are connected series connected module, a parallel connected module have some group of cells like that. Then that can be provided with one diode parallel to through it to minimize the cost of the diode and to avoid the complication and size, reduce the size of this one. To provide the all of the panel have another diode, and this is also have a diode and series connected series and parallel combination of the resistances, and there is another diode to this will be increase the size of the whole PV panel. Then for the large number of PV panel, there is just some grouping of series connected and parallel connected cells. Suppose this is the one group, then taken a simple diode across it and a series of this one, a diode like that to protect them. Okay, I think this is the completed of this one. If you have any questions, doubts, you can ask me.
Sir, actually, I have one question,
Yes.
general question. There is a VI graph, and we know generation is happen in only first quadrant.
Hmm.
But if we reverse the graph, vi not in x-axis we consider current, and in y-axis we consider voltage, then which quadrant the generation will be happen?
Same thing. If you talk about the generation, then voltage and current should be a positive direction. Then that condition power should be generated from the source. If you talk about the load and that same condition, the load will be like work like a sink. If a positive current, positive voltage positive. If you take anything, you can take this is a positive current, this is a voltage. If you talk about the source have something like that. Suppose it's simple, I am taking a voltage source and current I. This is a positive, this is a negative voltage. Then this will the direction of current. If you take this direction of current for the source, then this is the positive direction and voltage is also positive. The voltage is positive, current is positive. This is the source. If this source at any time current will be reverse, suppose at any time, then what happened? Current will be here, and this condition this will be work like a sink only for the source. Same thing if you talk about the any direction, if you take this is because of the it is the standard that if your current is leaving from positive terminal of a source, then that source is works like a source only, that not a sink. If same source have current is entering from the positive terminal, and that source work like a sink. Suppose in case of battery, now in case of battery, if you charge the battery, then what happen? Current flowing through battery from the positive terminal. Suppose same thing, I have connected a battery here. Sorry, I connected some resistances because of the some internal resistances of the source of the battery. This is the battery. Same thing is the positive terminal. Current is same direction. Voltage VB and current, suppose this will be IB RS. Then what happened? When the battery is charging condition, the current is entering from the positive terminal. Then this terminal is this phenomena is known as the sinking phenomena, and battery work like a sink only because the battery is charging at that point. In this condition, you can say it battery is working in this coordinate. Of same battery, if you want, same battery is working in a loads. Suppose RL. In this condition, what happened? The battery positive terminal current is leaving from positive terminal and entering through the negative terminal. This is the series resistance of the battery. This is the RL. Then what happened? This thing both are positive, VB and IB. In this condition, battery is working like a source. Then in overall condition, same thing. If resistances also, you know, if a current is passing through it, that this will be a positive, this will be a negative, because of the current is entering from the positive terminal. If a current is entering from the positive terminal, if any sources or any element, and that thing shows that that element is working like a passive element, or this is the sink, power dispersal is there. But same thing, if a current is leaving from positive terminal, this will not happen in the resistance cases, because if some active element like a diode and like a transistor, so it's diode, not a diode, transistor and amplifier, sometimes it will be positive from leaving sorry, leaving current from the positive terminal, and that condition this will be working like a source. That's why this will says the, I think, active element of the amplifier to amplify the active terminal. The same thing, don't be confusion from the coordinate system. If the any sources have some voltages and have some current, if the current is leaving from the positive terminal, or if given as some references, or there are given some references like that only, then what happened? Current is flowing through positive terminal, from the positive terminal, a current voltage also positive. The voltage is positive, current is positive. Then that will be work like a source. Same thing, if you talk about the load, then what happened? Suppose I provide some load here. I have some voltages VL, current I, and what happened? Same, if you is depending on the current direction. If you taking a reference as the current direction of this one, then what happened? Current is flowing to positive direction and voltage also positive. Then same thing, this resistance working like a source. See, sorry, sink. If you talk about the resistances V R and IR, talk about the resistances, the same in same condition, resistances will work like a sink in same coordinate. But in source condition, if same coordinate I have working like a source. That's why there is not don't be confusion. Her every element have some coordinate axis, and it's depending on the direction of reference direction. What is given in the reference direction? If battery terminal is given reference direction as this direction, if current is flowing this direction, it means current is the positive direction, flowing through the positive direction, and take a positive, and voltage also positive terminal here. Voltage appears positive terminal. This is also positive. Then this source like work like a source. In same condition, if any if any condition, suppose here provide some voltage source V2 is more than the voltage from the V1, then what happened? Current is flowing through the opposite direction. It means current will be negative. As the current negative, then same source. is work like a sink. Then all over thing is depending on the reference condition. What is the given in reference of current and voltages? Okay, it's fine.
Got it, sir. Thank you.
Okay, welcome. Any other? I have some problem, or I want to wind up of this one here.
No, sir. Thank you, sir. Welcome.
Okay, okay, fine. Okay, everyone. Thank you for attending the class.
Yes, sir. Welcome.